Welcome back. So in this video, we're going to be looking at how we can use Copernicus to do slap comps for combining VFX elements with a live action plate. So this is going to make use of things like the Background Plate LOP, where we're going to be doing all of our compositing inside of Houdini. To start with, I'm going to be using a still image. So I just have this one over here. I got this off of Pexels, and it's just the street, right? The reason I'm starting with a still image is so that we can get some of the foundational concepts understood before we move on to a more complex scene. So this is all we have to start with. And there's a couple of things that I want you to notice. Firstly, there is some level of post-processing on this image already. You'll see that the shadows are not pitch black, and they also have a bit of a blue tint to them. And generally the image is slightly low contrast. We also have to look at things like lighting. So our lighting is very diffused. So there's a high turbidity sky. So we can use that when we're busy setting up our calmer physical sky. As you go further back in space, you can see that there's some mist. So we can do something like that with a depth pass. And so I'm going to be showing you all of that in this video. So first things first, we need to match up some geometry to that scene that we just saw. So we can just navigate around and line up a camera with one of our axes. I'm going to go onto the Z-axis over here and place a camera. Now with this camera, let's just change the rotations over here. We're just going to zero it out. We'll have -180 on Y, and we'll zero out our translate. Now, as for the Y translate, let's look at that image again. It seems as if we're basically just standing on the road. So we can assume that this is going to be something like 1.7, 1.8, 2, anything around there. Now let's go ahead and set up a grid to represent the road. Now it's going to be a bit difficult to set up the grid unless we can actually see that image in our viewport. So to do that, we can go over to the camera view, scroll down to background image, go over to our image sequences and just choose that image. So now we can see it in our viewport. And if we go ahead and now drop a grid, you won't be able to see it because it is behind our camera. So let's just dive inside here and let's extend this road out. Right, so we're going to extend it in the direction of our camera. So I'm going to do a quick expression, copy the Y component, paste it under center. So paste relative references and then divide it by 2. That'll just keep it at the origin. And then we can just extend it out. So we're going to assume that that road was something like 200 meters. Something like that. If we take a look from our camera view, it doesn't perfectly align just yet. So there are a few changes that we'll need to make. So I'm going to press W to make this wireframe, and you can see that our road actually extends upwards. So what we want is to adjust our camera's rotation. So go back over to your camera and just increase the X rotation until it starts to drop towards the horizon. Something like that. Now we can also go over to our view, and I'm going to decrease our focal length to something like 30. Between those two, you should be able to find a point where this mostly matches your road. We can also make a slight adjustment of the translation on Z and Y so that this aligns more accurately. Okay, so this doesn't need to be perfect. That will be good enough. So we have our road set up and we're good to move on from there. So right over here, we'll just call this street shadow catcher. And that's because the main function of this is to catch any shadows and reflections that are going to be cast by whatever object we put in our scene. So when it reflects on the road, and then we need to composite that reflection onto the road, this is the object that's going to be catching that reflection or the shadows. So now we can go ahead and add a geometry. I'm just going to add a cube. So we can just call this hero object. This is just going to be the object that we're adding. And inside of here, we'll start with a cube to keep it simple. I'm going to bevel it slightly, just so that's a little bit more interesting. So we just have this cube. And now we can place it anywhere along our road. So I'm going to use a transform node, grabbing the cube. So I'm going to move it along, shift it up. So now we just have this cube that is floating above our road. We can move it towards the center and give it some rotation. Something like that is fine for now. Okay, let's add a null. And this null is just going to be for reference. So we can call this hero object out. And now we can go over to the stage level. At the stage level, we're going to use a SOP import. This is going to be to bring in our shadow catcher. So we grab our shadow catcher. We now have our road over there. Rename this to shadow catcher. We're going to use another SOP import. This one is going to be for our cube. So hero object, rename this to hero object. Keeping in mind that the path prefix that will be used in our scene graph tree is going to be the name of these nodes. So by simply changing the name to shadow catcher, our road will have that name in our scene graph tree. Next, we want to import our cameras. So we'll do a camera import, scene import cameras. This is going to bring in our camera. We can now look through our camera view, and you can see that everything is still lining up. Now, if we go ahead and go into a Karma XPU render, you'll see that we have this sphere and our grid and not much else. So the one thing that we may want to do is just add a material to our cube. We can do that with a material linker. I'm going to keep it simple. Just using a material linker is a nice way to just add from our catalog. So we have this catalog of materials, and I'm just going to throw asphalt onto our hero object, right? So that's all it is. The next thing that we're going to want to do is just add a light source. So we'll use a Karma physical sky. So we can say render light geometry, disable that. When you add your Karma physical sky, you'll notice that your background disappears, but that's okay. So we'll come back to correct the sky, but what we want now is to reintroduce our plate and apply the shadows to it based on this shadow catcher and object. We can use a Background Plate LOP for that. So Background Plate, plug this in. Now the primitive that we want to select is the one that's going to be catching shadows and reflections. So the primitives up here, those are the ones for shadow catching and reflection catching. We can just go and set this to shadow catcher, and you'll see that it disappears. Additionally, we can choose a plate and we can choose that image. This will reintroduce it into our background, but you won't see it in your viewport until you use a Karma render node. So let's go down here to Karma, plug both of these inputs in, and there you'll have it now showing up in your viewport. The one thing on this Karma render settings node is that we want to be fetching AOVs from this Background Plate LOP. Now, what exactly are we going to be fetching? Well, if we go to our Karma physical sky and then into our viewport, you can see that we have these few render outputs: color, depth, normal, primvar, primID, instance ID. However, when you use the Background Plate node, it actually generates a bunch of other ones for you. You will see that they don't show up over here in your Karma render settings, but there should be things like shadows and reflections. The way we get access to that is by going over to the image output tab of our Karma render settings and just say import render vars from second input. Now, if we take a look, you'll see that we have our shadows. Hold out diffuse, hold out shadows, and those are the two that have been added. You'll also see we have a shadow being cast on our road, and that is because of the Background Plate LOP. So if this isn't making sense conceptually, understand that what we're doing is we're bringing in a shadow catcher or a reflection catcher that matches the geometry in our scene. I chose a road because it's super simple to just match that geometry up. We then have a hero object, and that is the object that we actually want to render. We bring in our camera that lines up to the road and our geometry. Then the background plate needs to know what we actually want to render and what we want our shadows to be caught on. So we tell it that we want our road to be the thing that shows our reflections and our shadows. And then we choose the background plate image, and it applies those shadows and reflections to our plate. Now, you may notice that we don't actually have reflections. That's very simple. That's because on this background plate node, at the bottom, we have the AOVs that we would like to add. And so we can go to glossy reflection. Once we do that, you'll also see the reflection of our cube. That's going to be not exactly how it is in our scene, and that's because our roughness is simply too high. We can reduce the roughness over here to make it match more closely to our road. Something like that looks a bit more accurate. Now let's make some adjustments to our lighting so that it more closely matches the actual scene that we have in our plate. Go over to your Karma physical sky and increase the angular size. This is going to soften your shadows. And then we can go over to the turbidity and increase the turbidity to a very high amount. Right? Once again, that also softens your shadows, but it softens the general lighting in the scene. If we take a look at where our light source is in this scene, it is a little bit difficult to tell, but we can see that the left side or the side closest to us is in shadow. So it looks like the light source might be more or less from above, slightly to the right. So if we want to match that up, you can actually see which direction our Karma physical sky is pointing if we look at it here. And then we can make those adjustments. So you can see pointed further down, and we want it slightly to the right. So we're going to do something like that, right? Go back to our camera view, XPU render. This is now what we have. Okay, so up until this point, we haven't actually used any of the Copernicus nodes. This has just been setting up the background plate LOP, but the important thing about this was actually fetching our AOVs from this background plate node, because now we can actually make use of it. So I'm going to just switch this to Karma CPU, and you will notice that there is a difference in our reflections and our shadows. So when we look at Karma XPU, it's extremely dark. When we look at CPU, it's more accurate. So I would recommend using CPU if you are going to be using this workflow. And I do believe it's because of the background material that is generated inside of the background plate node. You can dive inside and make changes to that, but I believe that it is vex-based and that does not work with XPU. So we're going to be using CPU for this. And now we can go ahead and make some changes. Clearly this cube is too dark to fit into our scene. The black levels are much too dark, and it would also be nice to add a little bit of distortion to our reflections. So we can do that. Let's add a cop network over on the side, and this is just going to be for our slap comp. Cool, so dive inside of your slap comp, inside of here, a block begin. So we want the slap comp block. That's going to bring in everything from our viewport. We can go to the composite view, and you can now see that this is what's in our viewport. Now, the one thing is we are bringing in our background because of our background plate node, but we don't actually want that. What we want is to bring it in over here in our slap comp and actually composite it ourselves. So to do that, we simply remove the plate from our background plate, right? So now we go back to our scene view. You'll see that it just renders our cube. Then when we go to slap comp, all we have is this cube floating in space. Cool. So let's just clear both of these. So we can clear our slap comp import and our block begin. We can even clear our block end. Then go over to the slap comp import and say add AOVs from last render. This will connect up everything that we have connected. And we only want to keep the ones that we have explicitly created. So we know that C is always going to be created because we need some sort of output for our render. But then we also have holdout, diffuse, reflection, occlusion, and shadows. All of those were generated by our background plate LOP. These three at the bottom haven't been explicitly created. So remove those because those can cause issues at a later point. Again, removing them over here. And finally, just adding a block output. All we want is C as our output. There we go. Now we can bring in our background plate. So use a file node. With this file node, we're going to grab it. We can now use this with an over operation. So this is going to be our background. So put it into the background input. C is going to be our foreground. And once we do that, we have our cube floating in space. Next, let's work on our shadows and our reflections. So to view this, I'm going to go back to the block begin and let's see what we've actually generated. So we have our holdout, diffuse, our reflections, our shadows, and our occlusion. So reflection, occlusion, and our actual reflection are going to be used in conjunction. We'll use the occlusion as an alpha mask for where we want our reflections to occur. As for shadows, you'll see that it comes through as white. So we need to invert this and that'll give us our shadows. So those are two separate things that we want to do. Firstly, we're going to grab our shadows. So that's the last one over there. I'm going to use an invert on it. You'll see that it just gives us a slight shadow. And all we have to do is run that with a multiply with our background plate. So before we actually put in our render to this over, we're going to multiply our background plate with our shadows. Right, so we've taken our shadows, we've inverted them and multiplied them with our background plate. Right over there, you can see that it adds that slight shadow. However, we also want our reflections. So we have holdout reflection and holdout reflection occlusion. What we're going to do is combine them together to create a reflection channel. So we're going to use a channel split. All this does is splits up RGB or RGBA into its components. We're going to grab our holdout reflection, plug that into RGBA. Then we're going to use a channel join over here, taking in the three that are provided by our reflections. So all we're doing is we're splitting and then joining. So as you can see, we have our shadows down there. But the problem is we don't have an alpha channel. You can see it over here that there's no transparency grid. So we're going to bring in our holdout reflection occlusion, and that's going to be the third input for our alpha. You'll see that it throws an error, and that's simply because we're going from RGB to mono. So let's do that conversion, RGB to mono, plugging that in over there. And now you can see that we actually have alpha, right? So we're using this occlusion mask as our alpha. Now we can do the same thing that we've done here. So we're going to use an over operation. So after where we've added our shadows, let's just add our reflections. Just like that, we now have our reflection showing, and then we add our cube back in. Okay, cool. But you will notice that there is some texture on our road, and it's distorting all of these other reflections very slightly. And so what we can do is we can do that same distortion over here. Let's move this over, and let's do some distortion on our reflection. So we'll use a distort node. You'll see that as we push this up, it just moves over to the side. That's not what we want. We want a noise. So we're going to drive this by a noise. Just a fractal noise is going to be fine. Over here, we're going to expand out the element size and just increase the element scale on the x-axis. That's going to give us this stretched texture. We can then reduce the element size to something like that, and then just convert this to a UV channel. right? So once we have that, plug that into our distort, and let's see what it's doing for us. So as we push up the scale, you'll see that it pushes up to the top right. That's simply because of the center of our noise. Bring the center back down to 0, and now it's doing what we expect it to do. So as we push up the distort, it causes some distortion in our reflection. Now we can just decrease this element size even further, give it some roughness as well, further decrease it, and then adjust the amount of distortion. So there we go. We now add a slight level of distortion to our reflection, and that looks good. Now, as for the color corrections that we want to create, we want to lift up the black areas. As you can see, there is no pitch black in this, but we do have black over here. All we're going to do that is a remap node, plug this into your remap node, extend it out, and bring up the low end. You'll see that as we bring this up, it decreases the contrast of everything. That's not really what we want. We only want it occurring on our cube and on the reflection. And in some cases, you'll want it on the shadow as well, but it's okay for us to just do it on the cube and the reflection. So that just means that we need the cube's alpha, the reflection's alpha, and then use that as a mask for where we're applying this sort of contrast control. We already know that we have our reflection alpha down here, but that means that we also just need our alpha from our cube. To do that, we can grab the C channel and do a channel split. After this channel split, let's combine those two alphas together. The way we're going to do that is with a maximum operation, and then take these two alphas. You'll see that it gives us this, and that's perfect. So we can now take that and use that as a mask for our remap. You'll see now that it only affects our cube and its reflection. So increasing that slightly already makes this blend in with the rest of our scene a lot better. But the next thing that we want is to add this bluish tint that we see in our shadows. To do that, we're going to go RGBA to mono. This is going to give us the values of our entire composition, right? So it grayscales everything. And then we can use that in a ramp. So we'll do ramp RGB, putting this into position and the size reference until we have that. Now you can see that we can target shadows and highlights separately. So I'm going to add a bluish teal tint to the shadows and perhaps a yellow white tint over there. I'm going to bring up the shadows, bring in these ranges a bit, and it's going to be difficult to tell what that's doing until we use another blend node. So blend, grab our remapped image and our colors, and on this blend, we're going to set the operation type to color, and you'll see that it almost applies this color that we've created as a filter. Now, the only thing is we also want to mask this. So once again, we'll grab our combined mask from the bottom, masking it to only affect this. Of course, that is much too intense. So we reduce the amount until it starts to fit in. Great, so that's starting to fit into our scene a lot better. The only other thing that you might want to do is something like a fake light bleed. So around the edges over here, you might want the background lighting to bleed over onto our foreground element. Now, the way that I found to do this that is fairly interesting is by taking our C channel's alphas and working with that. So down here, we have the alphas for our C channel. What I'm going to do is run a blur. So we have this, increasing the blur, then running an invert. So we have that, and then running a multiply. So what that gives us is the edges of this cube. If we reduce this slightly, you'll see that that's what we end up with. You can also do edge detect based on things like depth or normals. I'll just be doing it this way. This seems like a pretty easy way to do it. Then we're just going to take a screen node, and with that screen node, we can take the background plate plus our added cube, and what we're going to screen over it is our background plate. Now this might seem a bit strange, but it'll make sense when you bring in the mask, right? You'll see that it causes this weird sort of look where everything gets brighter, but now we have a mask to work with. So we grab the mask that we created down here, drag that into the mask for our screen, and you'll see that it does that to the edges. The only thing that you have to do to make this more believable is something like a blur, blurring that background plate that we're using, and then reducing the amount of effect that this has. So it takes us from this to this, and that makes it somewhat more believable. You can also soften the mask even further down here. And by doing that, we sort of mimic light bleed. You'll see that the edges over there, where we expect it to be a bit brighter, tend to be a bit brighter. Take that, plug that into your remap, run all those same operations over it, and make adjustments where necessary. Once we're done with that, we can just plug that into our block end. Once we have all of that working, let's go back up to our viewport. And there's a few things that we want to adjust before we use this as a slap comp. Over on our Karma render settings, let's just make sure that we're using the correct camera. So that's /cam1, and we'll set this to HD. Once we have that, let's go to a Karma CPU render and then enable our slap comp. And as you can see, it applies it. We can just hide our grid, and this is working quite well. Now, the cool thing about this is that we can just throw in any geometry we want. So let's replace this with a rubber toy. And that works as well. So we can move this down. And as you can see, it works really nicely. You can also do further adjustments at the end. So once this has all been put together, you can add things like a vignette or grain or whatever you want, especially if you have any of the OFX plugins. But we can even just add something like a glow and a bit of chromatic aberration. If you find that the edges of your geometry are slightly too sharp, you can do a blur where you're adding it over your plate. So we grab its mask and then blur it. And if you do a very slight blur on that, it will remove those harsh edges. And then we can still go about doing everything that we had before. So there we have it. That's how we create still images with Copernicus, slap comps, and background plate nodes. Next, we will be looking at how we can use video and video image sequences to do this exact same thing, but integrating things like camera tracks, object tracks, and other elements. But that's all for this part. I'll be seeing you in the next video. Until then, bye.